Okay, hi everyone. I hope this video finds you well. So today we are going to talk about local classes. We are going to talk about anonymous classes, function interfaces, and finally we are going to conclude with Lambda expressions. So we found that we have a problem in where sometimes there are times when you want to specify just a single function. So you don't want to create a class to define this function inside, and when you want to use it, you have to create an object of that class. So the Java community came up with some solutions. So over the time, Java introduced different solutions to this problem. So early in Java 1.2, they introduced the anonymous classes concept. More recently in Java 8, they introduced Lambda expressions. So we are going to start going gradually from the anonymous classes until we end up with Lambda expressions, and we will see what is the difference and how easy it gets when you have the Lambda expressions in your hand. So let's take a look at this class. We have employee class, and this employee class implements the comparable. We have done something similar to this before, but we have implemented comparable, and in comparable, you have to provide implementation to the compare to function. You have to override it from this interface, and you have to provide it with implementation. So if we are loading our employees from CSV file, this is exactly what you are going to be doing at the end of this lecture. You have an exercise where you load the employees from CSV file. Then we have shuffled unsorted employee array list, and we are going to sort it. Now we can use just collections.sort. This collections.sort is going to look for the employees because it's of type employee, this list. So it goes to the employee compare to, and compares based on this criteria, which is comparing just the IDs. So this is what is this program doing. So what if we wanted to sort in the opposite order? What do you think we have to do? So we don't want to change compare to, because compare to is comparing based on IDs, and you cannot have two compare to functions exactly like this, because this is not a valid overloading of the function. So what we are going to do is a simple solution. One, we are going to create another class, a new class that implements comparator interface, and in this comparator interface, we have a function called compare. Now, compare takes two parameters of the type you have. So we have two employees, and we define the other criteria. We were doing first.id compared to second.id. Now we are doing second to first. So we are actually doing the opposite order. And now when you have collections.sort, now you can call collections.sort on the unsorted array list while providing it with the object of this class that is newly created. So we found a solution, but this solution is exhausting a little bit because you have to create a class, you have to implement the correct interface, and eventually you have to create an object in here. So do we have something a little bit simpler than this? So yes, we can do that using anonymous classes. So an anonymous class is a local class without a name. This is why it's called anonymous, because it does not have a name. So anonymous class is defined and instantiated in a single succinct expression using the new operator, So here is introduction to local classes. So you have seen this before or something similar to it when we explain nested classes, right? So this is pretty much similar to that, but a local class is going to be whether it's inside a class or inside a function. So we have a function in here. It's called enumerate, and it returns enumeration type. And we have a local class called enumerator, and that class implements the enumeration type. So we have done something eventually, because this local class is, or this function is returning an enumeration object. We have this class, and when you define it, you can eventually, because you still have access to this one, you can return a new enumerator. So this is not that complicated. You have a local class, you define it when you need it. When you create or when you call this function, right? When you call this function, only when you call this function. So when you call this function, this class is going to be created, and then you can create an object out of it and return it as a return type of this method. Okay, so this is local classes. So why local class definition is a statement in a block of Java code, an anonymous class definition is an expression. So this is a complete statement, right? Or a block of statements. The anonymous class is an expression, which means it can be included as a part of a larger expression, which we are going to do today, such as a method call, not a method definition. So a block can be in another block, nested blocks, right? So today we are going to have an expression, even though this expression could be of multiple lines, which is usually we use to call it a block. But today we are going to have it in a method call. Everything is going to be cleared up when we have examples. So when a local class is used only once, consider using anonymous classes syntax, which places the definition and use of the class in exactly the same place. So instead of having local class where you have to create the whole class with the name and with everything inside, you can just do anonymous classes syntax, and this is going to places the definition and use of the class in exactly the same place of the local class. So one of the most elegant things about anonymous classes is that they allow to define one-shot class exactly where it's needed. One-shot class exactly when it's needed. So we're going to do that, and we are going to do that exactly instead of creating a totally new class, a whole new class outside and create an object out of it. We can do that in a function call, in a method call. So in addition, anonymous classes have a succinct syntax that reduces clutter in your code. So because of that anonymous classes, they're just a type of local class. Anonymous classes and local classes share the same restrictions. We are going to have some differences, but they share pretty much the same restrictions. An anonymous class cannot define any static field or methods or classes except for static final constants. You can only have static final constants. Interfaces cannot be defined anonymously since there is no way to implement an interface without a name, right? So you have to do implement, then you have to provide the name of your interface. If you have an anonymous interface, then you cannot have this name, right? So you cannot have anonymous interfaces. However, you have anonymous classes. So also, like local classes, anonymous classes cannot be public, private, protected, or static. So they're by default default, so package private. Since an anonymous class has no name, it's not possible to define a constructor for the anonymous class. And why do we say package private, or they don't have public, private, or any extra type? Because they're only going to be used in that place where you define them. So if your class requires a constructor, you must use a local class instead, not anonymous class, because you cannot create a constructor, you cannot construct an object of a class without a name of that class. So, however, you can often use an instance initializers. Those are blocks that are going to be those are going to be executed before the constructors of the class. We're not going to cover instance initializers, but you can go to this link and try to read about them. So, in fact, instance initializers were introduced into the language for this exact purpose. So, sorting using an anonymous class. We used objects before to sort. Now, we are not going to use object and then we are going to create, we are not going to create a class, entire class, then we use an object out of this class in here. Instead, we are going to start our class definition with new comparator, and this is, if you remember, this is your interface. New, then interface, instead of saying class blah 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 implements that interface. No, we would say just new, replace the whole thing new, and this interface in the function call. In the function call itself. The sort is a function, right? So in the function call itself, we give it the list, the same way we did before. And now we're doing new comparator, and you open brackets and close them exactly like if you are in a class. So inside of a class, you're going to implement the method in that interface. Method that inside of that interface. So this is anonymous classes. Anonymous classes, we're doing new, then we do the implementation of the function inside that interface in here. And since that is a function, here is the opening parenthesis and here is the closing parenthesis, and don't forget that you are still inside a function call. So this is a statement. This is one statement. Don't forget this semicolon. Okay, let's talk now about anonymous functions. Anonymous functions originate in the work of Alonzo Church and his invention of the Lamda calculus in 1936. Those were way before electric computers, in which all functions are anonymous. So an anonymous function, or it's called also function literal or lambda abstraction or lambda expression, is a function definition that is not bound to an identifier because it's anonymous, so there is no identifier, right? So anonymous functions are often arguments being passed to a higher order functions or used for constructing the result of a higher order function that needs to return a function. Return a function. And we are going to have an example of those. So in several programming languages like Python, Java, and so on, anonymous functions are introduced using the keyword lambda. And anonymous functions are often referred to as lambda or lambda abstractions, either just lambdas or lambda abstractions. So anonymous functions have been a feature of programming languages since Lisp in 1958, and growing number of modern languages, as I said, Java, Python, and so on. So we have in anonymous functions, they can be used for containing functionality that need not be named, and possibly for short-term use. for short-term use, like not being named, so we can have them in a function call, and short-term use only specific for that function call, not for any other use inside of the other codes on your program. So some notable examples include closure and currying. So closures and currying are read-only, so you don't have to fully understand them. But if you understand them, that is going to be better. So this is why I'm going to explain them briefly, so you eventually see where the Lambda expressions, which you have to understand them entirely, because these are the main concepts of today's lecture. But those things I'm going to explain briefly so we get to what we want. So closures. Let's start with closure. So closure is a technique for implementing lexically scope name binding in language with first-class functions. So those, if you're talking about local variables lexically scoped. Operationally, a closure is a record sorting a function together with an environment. So if you still don't understand what that means, it's going to be cleared up with the next example. It's going to be in the next few slides. A closure, unlike a plain function, allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside their scope. So the function could be invoked outside of their scopes, but the captured variables can still be accessed. Here's an example of closure that will clear everything up. So the environment is a mapping associating each free variable of the function, variables that are used locally but defined in an enclosing scope, like those, with the value or reference to which the name was bound when the closure was created. So I'm going to explain this, and you can keep an eye on what I'm explaining in here and this explanation of this. I provided this explanation for you. So when you review the slides, you can have it on you, and you can understand what's going on in this square. Okay, we have a function called add that takes x, and we have an embedded function called addx that takes y. This function, this specific function, returns the result of the addition of y plus x. And this function eventually return addx. So let's see how we are going to use that. So we are going to call a variable, and this variable is anonymous, so you don't have a type for that variable. And we are going to call it add1. And we are giving that variable add, the function add, and x, we are giving that 1. So we have add1. So where is x? You're going to replace each x in this function with 1. So we replace this with 1. So now we are returning add x, which means we are returning this one, right? Now we have a function. We have a function in here. So we can replace this because this is the result of this, right? We have a function that would need y to give you the result of y plus x. So we have add x that would need y, right? So add 1, it's called add 1. So we have eventually add 1 that needs y. So if I do add 1 and I give it 3, this is y, right? So now go back in here, that was 1. So now you give it y, 3. 3 plus 1, 4. 3 plus 1, 4. Okay, so let's do that again. That becomes more obvious. So add 5. we give it 5. So plug in the 5 in here. So we have add x. So this becomes 5. This becomes 5. We return add x. So add 5 needs a y to be added to the 5. So add 5, give it a y. This plugs in, this plugs the 3 in here. Now 3 plus 5, return that, and this is your 8. This is your 8. Okay, so we have something called currying. So currying is a technique of translating the evaluation of a function that takes multiple arguments or a tuple of arguments into evaluating a sequence of functions, each with a single argument. So basically it provides a way of automatically managing how arguments are passed to a function and exceptions. What do you mean by that? I mean, let's say we have a function f of x and y equal x times y. So let's define that function that will multiply two arguments. Multiply x times y. So translating this, the correct form of this function in Java 8 would be, here is the correct function, int function. We can define it as int function because x and y are going to be integers. Int function, int unary operators. We have unary operators for those. Curried function, call it curried multiplication. And we say a and b representing x and y. This, when you get a and b, the two numbers, do this. Multiply a and b. So a times b. A times b. So this is being carried right now. This is being carried right now. So here is the thing we have just done, right? So if we are applying this function and we want the result of 2 times 2, we're going to say print what? Print this function. Right now, this function needs two things to give you a result, right? Here is one. We say dot apply the first two. Dot apply the first two. Now we have a function that has a but waits for the b. Waits for the b. When you do dot apply as int or just apply dot apply to but because we have it as int function, you do have to do apply as int. When you do a apply as int 2, this is your b, and now you get a result out of all this. You get the result of 2 times 2, which is 4. So if we have our chord multiplication and we do dot apply 20, now you have 20 times b. It's waiting for your b. So you do, if you put that in the int unary operator, because it's of that type, then you have partial multiplication, dot apply as int 1 times 20. Apply as int 5 times 20. Apply as int 10 times 20, and so on. Here is the result of each operation. Now, if you didn't understand that, it's okay. Here's another example that would make it a little bit easier. So here is, you can read the comments if you don't understand that fully. So we are going to create a curried function for adding u and v. For adding u and v. So we are going to have a function that would take an integer, and two integers in the function. And we are going to call that curry adder. Curry adder. So this function, we define that these two u and v are integers. And this is your function. So we say when you get a u and v, add them. So curry adder that apply to, this is your u, Did apply 3, this is your v, then this whole statement is going to give you 2 plus 3. That easy. You don't have to do that because this is not what today's lecture is all about. But this is an introduction that will give you a hint of what to expect from the next few slides. So again, if you didn't understand fully, still okay, but I think I explained them pretty well so you understand them. If you don't understand them, never mind, because this is not what's all about in today's lecture. Today's lecture is all about anonymous classes plus Lambda expressions. So anonymous function, this is what it's all about. So use of anonymous function is matter of style. Using them is never the only way to solve a problem. Each anonymous function could instead be defined as a named function and called by its name. Some programmers use anonymous functions to encapsulate specific non-reusable code without littering the code with a lot of little one-line normal functions. In some programming languages, anonymous functions are commonly implemented for very specific purpose, such as binding events, callbacks, or instantiating the function for particular values, or many things. We are going to use those pretty much all these things in Java X. So wait for it. So before we start talking about Lambda expressions, we have to define something called functional interfaces. Simply put, functional interfaces are interfaces with a single functionality to exhibit. So for example, the comparable interface. Comparable interface is one function interface. It has only one function, right? It's called compared to, used for comparison purposes. Java 8 defined lots of functional interfaces to be used extensively in Lambda expressions. I'm going to put those functional interfaces in the last 2 slides of this lecture. Those are optional. You can just take a look at them if you ever want to use any of them. So more precisely, we can say a functional interface is defined as an interface that has exactly one explicitly declared abstract method. The qualification is necessary because an interface may have non-abstract default method. And you know, when I say explicitly declared abstract method, we usually mean the public methods in there, right? So this is why functional interfaces used to be called single abstract methods, SAM, interfaces, a term that is still sometimes seen. Now let's talk about Java Lambdas. Java Lambdas expressions are new and important feature in Java Standard Edition 8. Lambda expression provides a way to represent one method interface using an expression. And the Lambda expression is like a method. It provides a list of formal parameters and a body, which can be an expression or a block of code expressed in terms of those parameters. So the syntax to those Lambda expressions are going to be a comma-separated parameters, a comma-separated list of parameters, then the arrow, and the arrow is hyphen and the greater than on your keyboard, and then a body. And the body could be a single statement, a single expression, or a statement, a block, or multiple statements. So it could be something like this. We have default parameters and we always have them in parentheses. So if they are multiple, more than one, you have them in parentheses. So int a comma int b, and then you open the brackets. If you have a statement or multiple statements. If you have multiple statements, it's a must to have those brackets. If you just have one statement, you can abandon those brackets. So then this would return a plus b. So this is going to add a and b. If you don't have any arguments or any parameters, you can have empty parentheses. But you have to have the parentheses if you have empty statement. You have to have them. Here is one line block of code, or not a block of code, one line expression that just prints hello world. So in this one, it takes a string and print that a string. In this one, you don't have parameters, but you say it's 48 or return 48. In this one, no inputs, but you say return 48. So a lambda expression can have a 0 or 1 or more parameters. The type of parameter can be explicitly declared by saying int a, or can be inferred from the context by just saying a. In this case, it could be, if we have s, then it could be inferred as a string or integer in case I provided it with integer, and so on. So parameters are enclosed in parentheses and separated by commas, like this, if they can be inferred automatically, or int a, int b if they cannot be inferred automatically. String a, int b, float c if we have different types. Empty parentheses are used to represent an empty set of parameters like this, and you must have them if you don't have any parameters. You must have the parentheses. When there is a single parameter, you can have parentheses or you can abandon them. They are not mandatory. For the body of the lambda expressions, the body of the lambda expression can contain 0, 1, or more statements. If the body of the lambda expression have a single statement, the curly brackets are not required. They are not mandatory. However, it's always better to have them. And the return type of the anonymous function is the same as the body expression. When there is more than one statement in the body, then these must be included with the curly braces. It's mandatory you have them. And the return type of the anonymous function is the same as the type of the value returned within the block of code you have. Or it's going to be void if nothing is returned. It's going to be considered a void function if nothing is returned. So each lambda expression can be implicitly assigned to one of the interface called function interfaces. One of the interfaces called functional interfaces. So we have function interface called runnable, and this is needed if you want your program or your code to be run in a thread. So this runnable interface is a function interface, so we can use it with the lambda expression, like below. Now you can see runnable r equal empty parentheses and print hello world. So this statement is going to be printed in a specific or a single thread, not a whole process, just a thread of that process. So uses of lambdas. So the simple code in here that is shown in here is using a for each to print every element in this list. We have a list, we can say a list of integer list, then we say array, raise.as list, we have those elements, 1, 2, 3, 4, 5, 6, and 7. So using a simple for each is going to be for each element, integer, n, in the list, print n, right? But the new way, we are going to use lambda expressions. So the new way we can do, here is the list, the same thing. We can do list dot, here is the list dot, for each n in that list, print the n. So n, then the arrow, and system.out.println the n, right? Or simply, we can have in Java 8, if you use Java 8, you can use the double colon operator. The double colon operator is going to access every element in here, every element in the list, and execute this method on that element, println. So print that element in this list and add a new line using println. So here's another, a little bit more complicated, more complicated than the previous example. So we have a list of integer, the same list, and what we want to print a specific element or specific number of elements that we have a condition that applied on those elements. For example, if you want to print every element, we are going to use evaluate function. We are going to create a function called evaluate. We are going to give it two things. One is a list, our list, and then we are going to give it a condition. Now we are going to use a functional interface called predicate. Predicate is a generic functional interface. You can give any type you want. This is why it's generic. Representing a single argument function that returns a Boolean value. So the most important function in this functional interface is the test function. Now the test is a function that returns a Boolean value. So we are going to use it this way. So you give it a predicate, and this predicate is going to be represented by your Lambda expression. Lambda expression, we said, can be used for functional interfaces. So, okay, functional interfaces that need this functional interface needs a Boolean expression. Okay, we are giving that a Boolean expression. So we are saying for each integer in n, for each integer in a list, in this list, if the predicate dot test returns true based on this Boolean expression, if this returns true, print n, print this element. Okay, let's apply it one by one on this list. So let's try to do this list. So we give the list and we say for each element is true. So we don't have a condition. True, print every element. So we print every element. For the next one, we have evaluate and we have this list. We say false. So n gives you false. So basically we have no condition, and every time we check this, it returns false, false, false. So basically we don't print anything. No printing. This makes it a little bit more obvious what exactly we are trying to do. So the condition, if n mod 2 equals 0. So we're printing only even numbers, right? We are printing only even numbers. So we have our list, and we have n means n mod 2. So test n, test the element in this list. The first element, this element. Test it. 1. Is 1 mod 2 equal 0? No, it's equal 1. So don't print that. Okay, moving on. The next iteration in this for each. This element 2. Is 2 mod 2 equal 0? Yes. Yes. Then print this element. So print 2. Print 2. Next, 3. Don't print it because it's odd. Even, yes, applies, printed. Then 6 applies, printed. In this case, we are doing only the odd numbers. So 1, 3, 5, and 7, right? 1, 3, 5, and 7. Again, taking this. Is this n in here? What is the condition on that? N mod 2 equal 1. Test n mod 2 equal 1. What is n? N is 1. Trying 1? Yes, it does. So print it. It's odd. 2? No, it doesn't. Because it returned on the mod result is 0. So it doesn't. So the third, yes, it's odd, print it, and so on. For the last one, print only the elements greater than 5. Is the element greater than 5? Try those. 1 greater than 5, no. 2 greater than 5, no. 3, 4, 5, no. Then 6 and 7, yes, print them. Print 6 and 7. Okay, difference between Lambda expressions and anonymous classes. One key difference between using anonymous classes and Lambda expressions is this keyword. When using this keyword, for anonymous classes, this keyword means I'm referring to this anonymous class. However, in Lambda expressions, if you used this means the enclosing class. The enclosing class. So if I have a class, blah, 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 and this is your, this is the class I'm referring to. Basically, if I use this inside, if we go to this slide, if I use this in here, this means I mean this class, the main class. However, in the anonymous class, in here, in the anonymous class, this refers to the anonymous class because this, it has to refer to a class. Since anonymous class is a class, it refers to that. Since the Lambda expression is not exactly a class, it has to refer to a class, so it refers to the enclosing class. Another key difference between the Lambda expression and anonymous classes is the way they are compiled. So the Java compiler compiles Lambda expressions and converts them into a private method of the class. So this is thought as anonymous function. So it's going to be compiled as a private method. But this is going to be the anonymous class is going to be compiled as a class, not a function, not a method. Okay, back to our example, the one we have list of employees and we are trying to override them. Right now we are going to use Lambda expressions. So with the Lambda expressions, we can say simply that employee O1 and O2, employee O1 and employee O2, do this. Sort based on IDs of employee if employee 1 is greater than employee 2. This is high to low. This is high to low. Employee 1 is having an ID greater than employee 2. This is exactly the opposite. Low to high, we say employee 2, employee 1. Opposed to employee 1 to employee 2. Okay, so if you have multi-line lambdas like this, you have to use curly braces, right? You have to. And you have to use semicolons for each statement. You have to use semicolon for each statement. It feels like, sometimes it feels like the Java is punishing us for writing multi-line lambdas, and perhaps we have to take a hint. However, keep in mind that as we create lambda expressions, if we have larger lambda expression, the readability of your code will suffer, and it's becoming hard to test, and you cannot reuse a lambda expression, right? You cannot reuse it. It's for one time only, single use only, and it's for a short-term use. So these are the function interfaces. I said they're optional. You don't have to care about them, but here are they. We have a lot of these. Here is the double predicate if you're going to use double predicate, not the predicate we have used. Here is also another sheet of function interfaces. This is the one we use, that we were interested in the test function in the interface. Okay. Now there is no slides left. What I'm going to show you is the Lambda expression anonymous classes lab you're going to have. So when you go to your canvas, you're going to see this assignment page. This is the thing you want. This is the zip file you would need. So download this zip file. Download this zip file. I'm going to take that zip file. I already copied that in here. I copied that into a place that I can see. So when you copy that into a place you can know, like on desktop or whatever you want, unzip that. So extract all. Now, this is your extract file, right? So when you open that and you see those files, take the path, go to your Eclipse, import it, import that. I pasted that in here. Now I see Eclipse project. Now I have Lambda expression, and it's going to ask you to do certain things. So let me just close these. So you have an employee class that implements comparable employee, and I already implemented the compare to, and this compare to function, compare two IDs, this ID to the employee ID, and in the main function, I have called load employees. I implemented this for you, so you don't have to worry about how to read a file or how to handle exceptions or anything. Everything is ready for you to use. What I want you to do is to do the things I said, take action below. So we have an array list of these employees. And I unsorted this. I made sure that it's unsorted by shuffling them. So what you need to do is to sort this array list based on specific things. So one, create and use anonymous class to sort by first name high to low. Then create a Lambda expression that sorts low to high. This create anonymous class. You sort based on the first name. If you are going to use the Lambda expression for the second requirement, you're going to use low to high based on the last name. Then use a Lambda expression to sort based on the title. Then and when you create one, do it, try it, and try to print it so you can see your result that you sorted that correctly. And when you do the printing, you would use a Lambda expression to print all the elements of the unsorted array list. Now, unsorted array list is going to use these things, right? I'm going to show you how to do the first two, and you do the rest. So let me show you how to do the first one. So the first one and the first two, like this. Okay. So here is how we create an anonymous class. So what you need to do in here, you need to create all of these three. I would do the first one, the second one, and you do 3, 4, and 5. Okay? You do 3, 4, and 5. But first, you try the one I have in the video and the second I have in the video. Then those up to you. Okay, the first one is creating an anonymous class. Anonymous class, as I said, you're going to say anonymous class first name high to low. This is how what I named it. And I'm going to use it in here. I'm going to use it in comparable employee. So I have comparable employee. This is my interface, right? And I have a variable of that type. I say equal new comparator employee and compare employee first, employee second, and I do if first that get first name the character at 0. I can do that, or just say this. I can compare the elements to themselves, like character by character, or by just doing this. I'm going to remove everything in here, and I will just do return. And I'm going to rely on the string class comparator or compare to. Return first dot get first name, because I'm comparing based on the first name, right? Dot compare to, and I have to give it another string. The string is going to be the second employee. The second employee get first name, and that's it. That's it. So now this works. Now this will compare the first name of the employees and doing them descendingly, not ascendingly, because it's high to low. Okay, so let's see that. Am I doing them high to low or low to high? Now let's try that. Let's try that in the anonymous class. Print that, and this doing the first name based on the first name. So we need to make this second, because we need high to low. So second, and this is first. Now let's try that. We should have them from Z to A for the first name. Okay, Z to A. Z to A. Okay, great. So the second one is going to be compare one. Compare one. So compare one is comparing the last name and doing that ascendingly, right? Ascendingly, yes. Doing that ascendingly. Low to high. So I may do that. Oh, by the way, for this one, you don't have to store it in a variable. You don't have to store it in a variable. We can just take this. Let me just take this and go to sort without using the variable name, and I would do this. And I would do this. And this will still give me the same result. The same result. So I don't have to store this in a variable. Just wanted to let you know. Okay, the second one is doing compare, and I'm comparing them. Comparing employees. And again, you don't have to put that in a variable. You don't have to put that. It's always preferred to have them in a variable if you're going to do some things like this. We are going to try more than one, because if you put that in here, you cannot use it anymore. So I can do that in here, remove this, and this will still work and compare these low to high based on the last name. As you can see, low to high. So otherwise, you can just use compare one, which is of type comparator, and this will give you the same exact result. Here is low to high. Now, what I want you to do is do 3, 4, and 5. 3, sorting them by title. 4, sorting them first by title, but if you have equal title, then you would have to sort by level. And the third one you have to do is to sort first by last name, then by first name. And for this one, use the for each dot, the list, the unsorted dot for each, and print all the elements. Okay, when you're done, upload your file. So go zip your file when you're done. Let me just show you that, the one that has my solution. Keep them like this, and you can have anyone in here. When I grade, I'm going to look at what you have. So go to your folder. this and right click on your folder and compress it. When you compress it, upload it in this page. Upload it to this page. Okay, that's enough for today, and see you next time.